Hi, this is Dr. K. Rajendra Prasad. I am working as professor in the departments of data science and cybersecurity. Today my topic is bootstrapping and LEX. So bootstrapping is a very important topic in the compiler design regarding to the compiler constructions, because I want to make some refinements of the compilers every time it is required for innovation of some different programming languages. So here initially we define some compiler. After that we want to add some more functions. So in that case you make use of the concept is called as bootstrapping. So bootstrapping is the process of writing a compiler for a programming language using the same language itself. The meaning is initially you are taking some programming language is called as assembly level language program. So it means here I am taking the language is initially because of assembly language, assembly level language. It is a low level language. Means machine can know about assembly language instructions. Actually, machine understanding zeros and ones only. But you should give some instructions to the hardware by some mnemonic codes with the help of one particular language called as assembly level language. It is called as ASL. So assembly level language I am writing here. It is assembly level language or assembly language. Simply say called as assembly language. To write the short name is called as ASL. I want to define one programming language compiler using ASL. Suppose I am taking one programming language compiler is P1. So I want to develop the P1 compiler. It's called as P1 compiler. Therefore, with the help of ASL only. After that, you got the P1 compiler, or after some days, you are thinking that some functional parts are missing in the P1 compiler. So you want to add some more functions. Means it becomes a more functional part. It becomes more functional part. Means you want to add some more functionalities. You are assuming at that time you want to refine the compiler. You want to refine the compiler. So how to refine the compiler method? But now you take the help is P1 compiler is initially it is generated. Now we go for P2. It becomes the compiler of older version P1C and place some more functions. Means use the same language itself. You want to develop some newer version of the compiler. You want to interacting this kind of process. It is called as bootstrapping. So that what is the bootstrapping is? Bootstrapping is the process of writing a compiler for a programming language using the same language itself. Means initially you are developed the compiler is a P1 compiler. Using the P1 compiler, you want to go for newer version of P1. Newer version of P1. This is the meaning of using the same language itself. Means you developed initially the compiler of P1 using the assembly level language. It is the first step you have to proceeding. After that, you make use of that compiler, P1 compiler, the same language compiler P1 to develop another newer version of the P1. You may assume that it's a P2 or P3 compilers. So which are also use the same language. What is the difference between the P1 and P2 compilers? So P1 compilers maybe have minimal version of the compiler. You also for particular programming language. For the same programming language, the maximal version of the compiler you are getting after using the P1. You try for generating some of the newer versions. A typical version of the compiler that's called as P2 compiler, which also use the same language. Whatever language is used for the P1, we can use the same language for the P2. So this entire process is called as bootstrapping. So you understood. So what is the basic idea of bootstrapping is? Like some kind of cross compilers? Yes, true. Because of here you are taking the initially assembly language for targeting of generating the P1 compiler. Next, you are taking the P1 compiler. Using the P1 compiler, you try for generating another kind of version of the compiler is a P2 compiler for converting the given code into the final target language code is again it becomes a ASL assembly language code. So this entire idea is called as bootstrapping. In other words, I am saying that the same meaning but understandable point of view. I am writing here the another point is it is a process of a compiler written in a particular programming language to compile a new version of the compiler written in the same language. So this is the idea of bootstrapping. Next, we have to see the what is the process. What I explained the same steps, the same things are defined in this slide. Okay. Once again, I will repeat what are the stages of the bootstrapping is. The initial stage is you define the minimal version of the compiler only. You note down this minimal version of the compiler. So using either assembly language because of it is low level language. What do you mean of low level is because of machine can easily interpret that kind of language is called as a low level language. Or you can also make use of C. C is not completely high level language. It is a middle level language. It will accept the syntaxes of low level as well as syntaxes of the high level. So which are more convenient when you writing a compiler for one particular language and then the compiler actually it is called as a translator. It translates the code into some machine understandable code. So that purpose you want to design any compiler or any translator. Okay, you make use of some ideas because we cannot stop only with a single version of the compiler. After some days or after few days, we are thinking some functional parts are missing at that time. So what is the idea is nothing but bootstrapping. Using the bootstrapping idea, again, you try to extend this minimal version. You try to extend this minimal version. This minimal version of the compiler by adding some other functional parts, we are delivering some more higher version of the compiler for the same programming language. So it is the first stage we have to get it. The next one is this minimal version of the compiler is then used to compile slightly more complex version or typical version. You can say that compiler written in the target language. I said the same idea. So this process is repeating. What this process? This process. Okay. This step is repeating. What I take this one is so you are taking the source is a minimal version of the compiler, but your idea is you want to develop some other complex version of the compiler, a higher version of the compiler for the same programming language. This step is repeated many times until you satisfy you are getting it becomes fully functional. The program language becomes fully functional. Suppose you feel as now this compiler is enough for taking for considering some user programming vision or user programming ideas, then you have to stop the process. So until that, you have to repeat the same steps. So what you got earlier, the compiler, you can make use of the same compiler. Again, you try for generating the higher version of the compiler. Next level is this higher version of the compiler. Again, you take as basic resource and using that you are generating another higher version of the compiler. This process is repeated. This process is repeated until you are getting the fully functional compiler for the programming the language. So these steps these are steps you should follow in the process of backtracking. So I am showing with well-known examples and well-known ideas of the bootstrapping. So with this slide, we are verifying what I explained. The same things are there. Here you are trying for generating some initial level of a compiler. The initial level of compiler is called as name is C0. I am giving the name of the initial compiler is C0 using the ASM. Is a Machine Understandable Assembly Language code. Is called as ASM. Is a ASM is a low level language code. Using this low level language compiler, we are generating what the initial compiler is C naught for for converting our code into, again get back into the ASM. So this is using the compiler one. Now using the compiler one, what version of the compiler is generated? You clearly know that C naught version is generated. Is it right? So using C naught, you have to see in the bootstrapping. Earlier what you generate nothing but only for the C naught. Now you are take the C naught. Now you take the C naught. So using C naught, you try generating for another version, another complex version or another higher version of the compiler. The name is called as C. For the purpose is the compiler of C for converting the user code or user high level programming language code that convert into some, again the pattern is ASM pattern. So in the compiler 2, you are generating what kind of compiler is higher version of the compiler is C. So we are trying for initially C naught using what language is ASM, assembly language program code, and now you are taking the source is not ASM, okay, the source is C naught. You find it. So using ASM, you are generating a C naught compiler. Now you have got already C naught. Okay, C naught you are generated using ASM. Again using C naught, you are generating another higher version of the compiler is C only. Okay. Now this is the idea. So finally, with the help of these two steps, so up to now, so what compiler is finally generated is, what complex version of the compiler is finally generated is C only. So C is obtained not directly from the ASM. C is obtained from C naught. Okay, here I have shown that C naught. Again, C naught is obtained from ASM. C naught is obtained from ASM. So these steps are very important when you understanding of bootstrapping compiler. Again, I will show the hierarchical steps are how the C is generated. C is generated, the version of we assume some final version. Final version of the C is generated using the compiler is initial version is C naught. How the C naught is generated is using the ASM, is a pattern of assembly language vision code. So this you have to understand, this process is totally called as bootstrapping process. Bootstrapping the process. So bootstrapping nothing but you are trying for generation of the initial version of the compiler. Again, next time is some other higher version of the compiler using the same programming language compilers itself. It is a process of bootstrapping. So you have to see the same idea in this example. Okay, these two steps are illustrating the same idea. So how it becomes cross compilers, or how we can getting the idea of bootstrapping is. So now I am mixing the ideas here. How the C naught is generated. Okay, how the C is generated from C naught to C. Is it right? Then how the C naught is generated from the compiler of ASM. ASM nothing but is some kind of compiler. Assembly language compiler. It's called as assembly language compiler. Is it clear? It's called as assembly language compiler. Yeah, I'm ready clear. Use assembly language compiler. You are generating what compiler is C naught compiler. C naught compiler. Next level is so this is first you have developed. This is stage 1. Okay. Next you have come to stage 2 is using C naught compiler. Okay, using C naught compiler, you are generating is C compiler. C compiler. Suppose I am giving the idea is I am not feeling good as C compiler. I want to extend some other functional parts. So you have to extend the diagram is like this. But here space is not available. I am showing separately. This is a diagram you are assuming using C. Okay, I am generating another new version CN. Your target is you're converting whatever the code is from high language code to assembly language code. Okay, so means using C compiler you're generating the CN. Again, scene also not enough is not sufficient, okay, for our programmers. At that time you try for generating another version of the compiler. Now already generated is CN, you are generating the CN1, you are generating the CN1. Finally the convert code is entered high level language code into ASM only. So you have to see the generation of the compilers versions are like this. C not generated using ASM. Next level is C is generated using the C naught. Next level is CN using generated. CN is generated using C, and CN1 is generated using CN, like that. So you have to see it is a iterative approach. Until you are generating these kind of versions, high level versions, when you stop is you fail as it is fully functional. The compiler becomes fully functional. It becomes fully functional. Okay, suppose you feel as if CN1 is fully functional, you stop it. Okay, you cannot go for remaining other higher versions of the compiler. So you should remember this idea, this is a process of bootstrapping. It is very important in designing the any compilers, or when you go for any compiler constructions. At least you have to know what is the idea of bootstrapping yourself. So bootstrapping is not depends on the single step, depends upon the some iterative steps. So the first step is the minimal version is repeated. Second step is repeated many times until you are refining the versions, compilers, for example, say CN1, CN2, until you are getting the fully functional. The compiler becomes fully functional. Then you have to stop the process. It is the idea of bootstrapping. So the same thing is we get a compiler written in ASM which compiles C and generate code in ASM. And when next this slide is showing very important bootstrapping. There is a bootstrapping up to previous slide is bootstrapping. From this we interact with another idea is LEX. What do you mean of LEX is? So LEX is some kind of a program. So this already had defined here. LEX in the compiler design is nothing but some kind of a program. What purpose? You try for generating scanners, generating scanners, or it is also called as scanner is also called as a lexical analyzer. So whatever scanner, lexical analyzer do the thing is parsing of the tokens. Whatever that, these scanners or lexical analyzers also called as tokenizers. Now you know that Lex is nothing but some kind of program that can be used for generating tokenizers. This is a basic idea of Lex. So what the tokenizers? So what is the idea of tokenizer? Because of in the lexical analyzer, the very important thing is whatever statement is given by the user, the entire statement that you want to convert from the pattern is valid tokens. The set of sequence of valid tokens. At that time, you make use of the scanners or token. The another name is tokenizer. Is another you can say also as lexical analyzer. So the same idea we have to getting in this. So because of here, these tokens identify the lexical pattern. Yes, it is true. Because of whatever input there in the program, okay, it is suppose it's not in the lexical pattern, and it is not possible to generate the sequence of tokens, so sequence of valid tokens. So it identify that which are in the lexical patterns. Okay, that is the first duty. The second one is I think once it is recognized, this becomes this particular programming language statement becomes lexical pattern. It already in the lexical pattern. Then it do the second thing is convert the input text into sequence of tokens. For example, I am writing here if A is greater than T. Okay, this is lexical pattern. It is a lexical pattern. So means I think some keywords are there. You can separate, and this is separate. Some operators fancies on I think some symbol or this identifier, this is some relation operator, this identifier, this identifier, and this is also another symbol. Like that, it convert the input text into sequence of tokens. So what the sequence of tokens are? If, parentheses, A, greater than, B, and plus. Okay, this is I think idea of sequence of tokens. This entire statement is lexical pattern statement. It is a lexical pattern statement. So that's the basic idea of LEX. LEX nothing but is some kind of program. Okay, this some kind of program. LEX in a compiler design is some kind of program, and generate scanners or lexical analyzers is also called as a tokenizers. Means generation of the tokenizers or generate of lexical analyzers or generation of the scanners. It is the first idea of LEX. Okay. So after that, LEX will identify lexical pattern as any given input statement that becomes converted into some sequence of tokens. It is a basic idea. And now, so you have to see what is exactly LEX is. Is it some kind of program? We are saying sometimes you also consider it is some kind of tool, software tool. Okay, it is a software tool or it is a computer program. So what it will do is generate scanners, generate tokenizers, generate lexical list. That's the first thing. So the LEX tool, I think, what about it is some tool, and sometimes I'm saying this is a program. But majorly, you can also consider it as some kind of particular compiler. The compiler name is called as a LEX compiler. LEX tool itself it acts as some compiler. Sometimes it is a program. Okay, compiler nothing but it is also some kind of translator program. No, so LEX tool itself the compiler. We also mean it compiles the input and transform the input into input patterns. That's a lexical patterns. Already said no. So it is commonly used where we are using nothing but IARE. The expansion of the IARE is yet another compiler. So it is the idea means compilers we can make use of the initial compiler. The second time also it may be becomes another compiler for generating the some sequence of tokens. So that's yet another compiler and a compiler. And you have to see this I think some well-known ideas regarding to the what are the major functions of the LEX is. Initially I am taking the LEX source program because you feel as it is LEX tool nothing but it's some kind of tool or some compiler. What it will generate? Compiler nothing but definitely it will convert into some other target. So target may not be always assembly language code, maybe any other format. Okay, here the target is it can be generated into the file format. Suppose you assume the file is YY, this is a YY. It becomes YY that can be converted into a lexical compiler. Nothing but it is some translator. No compiler. The basic idea is the translator. It becomes a translator. So it will do convert the LEX source program into some kind of another file format is lex.yy.c. Means finally yy that can be converted into lex.yy.c. So because of so here the every program language statement is given in the YY source code that can be converted into the some more lexical pattern. I said no. This is it having lex.yy.c. It having some lexical pattern. So now again you make use of our C compiler. Okay. Once lex.yy.c generated, you can take as this is the input and you try to convert. Okay, some kind of a dot out. This began to some mission is expecting this kind of target form a dot out form. So lex.yy.c that can be converted to the a dot out. So means here I'm using totally for how many types of conversions, sir? Two types of conversions, sir. One is initially using LEX compiler. I'm taking first step is it will convert the any LEX program into lex.yy.c. Yy is a file name. Whatever file name is given. Suppose ABC is the file name. So the LEX the finally the output is yy.abc.c. And once you know this, I think the dot C nothing but it is using this is a C program, no? So next level you must use the C compiler because dot C is always it indicates that it is some kind of a C program. means all Excel pattern that can be formulated in terms of C program language patterns. So that's why you make use of the second step is C compiler. So lex.yy.c that can be converted into the some target code of the our machine is using the a dot out. So once know the you reach the a dot out, now it will ask suppose any input is required to it will ask to the user. You provide that input data here, the input stream. So finally generating the some kind of a sequence of tokens. So this I think totally for how many functional parts are three. Okay, these are the functions of the Lex. Means finally Lex is developed with totally for I think three stages. First two stages I'm taking the compilers only, lexical compiler and C compiler only. Last stage is for generation of the sequence of tokens. Okay, you can make use of the system or target code a dot out. Then it will convert the given input stream of the user to some sequence of tokens. So this is the idea of regard to the functions of Lex. The same thing is explained here. In the first step, the source code in the Lex language having the file name is using some file name. Previously, you have taken the file name is yy.l. Okay, so it is the input to the Lex compiler, and then you are generating I think yy.l that can be converted into lex.yy.c. So you have to make a here the program not yy, it is the yy.l in previous slide you consider. So now the input is must be because of the Lex source program. So you must extension with the .l. Okay, it indicates Lex source program. So not simply yy. You are taking the yy.l. Then only you are assuming yy is a Lex source program in terms of some with extension of l. You assume this for the Lex source program. After that, you use the Lex compiler. Okay, using the Lex compiler. Okay, you converting the given yy.l into lex.yy.c. So after that, once you generated lex.yy.c, so C nothing but using this now currently you are in the some C programming format. Is it right? So you make what type of compiler? I think C compiler. You must use the C compiler. So lex.yy.c using C compiler. Okay, using C compiler, it convert. Okay, another format is a dot out. So what the a dot out is a system expecting format. So that is a mission understandable format. That format is a dot out. That some kind of target code is generated here. Target code will ask the will ask to user what the input stream is. Whatever input stream is given that can be converted into input stream. Okay, that can be converted into some sequence of tokens. So this is basically you assuming, okay, or you're considering, not assuming, you're considering some important functions of the Lex. So here I'm providing the what the major syntax of the Lex is the declaration part and translation rules and auxiliary procedures. You must remember this is the Lex file format. So here declarations. What the declarations is? So the declarations are about usually in the programming language regard to the variables, regard to the data type of the variables. Okay, you find there some declaration that comes the declarations. Translation rules. So pattern and action. So majorly you are interacting in our programming language with some control statements, if statement and some other while statement, do while. Here you have to you can define some action, whether you are entering to the if statement or not, whether you are entering to the while statement or not. Okay, that comes under the action. Pattern nothing but some condition. Based on the condition, you can define the action of the control statements. Okay, so that is you should remember and come to the auxiliary procedures. So procedures nothing but is defining idea is functions. Okay, so in the C programming language, what are the user-defined functions? Very well. You want to create any new user-defined functions that comes under the auxiliary procedures. So the auxiliary procedures holds auxiliary functions. For describing what? For describing the some actions. The actions that can be defined with any statement that may be for any assignment statements, any computation statements, or you want to show that will be executed under the particular conditions. You can also make use of the some various control statements. So totally these three are included in the LEX file format: declarations, translation rules, and also auxiliary procedures. So here I'm saying the what the declaration for this is an example only. Let's file format example. For understanding purpose, I'm showing the what the example is a number. Number I am considering the number is a one variable. So what type of variable is it? It is a integer variable. It is a integer variable. Okay, that's a declaration. Whether you're declaring it is an integer or a character or string. So that comes under the declaration. And translation. Okay, it's an example is so this called as I think pattern. This is a pattern. Is it right? So this pattern is executed and this totally for the action. Okay, you are entering into the if statement is a true. It is a true. Then you enter into the if statement. It is not a true. I think you are not belongs to the if part and you come out from the if statement. That's describing the way of this way of describing is called as the if action. If action. So patterns and actions. Majorly can defining under the translation is a pattern and actions. And auxiliary functions. Already told auxiliary functions, but you want to create any user-defined functions generation of the prime numbers, generation of the Fibonacci series, or you want to define recursive functions. That comes under the auxiliary functions only. Here, the example is number sum. Okay, maybe the user thinking that the summation of some numbers. You make adding of some numbers that defined under the one particular function. Auxiliary function is here the example is int is a return type. It's function is a number sum is some kind of auxiliary function. So totally from this you're knowing that. So what is the idea of declaration? What the translation, pattern and actions and auxiliary functions. So mainly you're describing is so what is LEX nothing but LEX is some kind of tool or some kind of program. You also assuming here you make use of some LEX compiler for converting the some LEX source program. For example, yy.l that can be converted into the lex.yy.c. So once the .c is generated, the next in the step is you can apply the some C compilers and you can try to convert into a.out. So a.out is a system target code, and using a.out and it will take the some input stream what I provided in the programming or maybe during the execution of the programming what I provided the statements in the input stream that can be converted into some sequence of tokens. So these three are the total functional parts of the LEX. And come to the ideas are declaration. What LEX file format is? It may have the format is declaration and translation and auxiliary functions because of all the variables should be declared. You take any program language that is necessary. So that comes under the declaration, and the next one is the translation. It may have it has the some kind of a pattern. Sometimes it may consist of some actions also, patterns and actions. So when the pattern is I think true, the corresponding action is defined. Here, for example, I given the if statement and auxiliary functions. User wants to create any user-defined functions or his own functions. Okay, that case you make creation of some functions. That functions under the assuming auxiliary functions. So I think this is the idea in today class. We got into the what is bootstrapping and LEX. Bootstrapping means mainly you are using for generation of not only for minimal version of the compiler. You can also trying for some other complex versions or fully functional version of the compiler. That case, the bootstrapping is very important. You make use of the bootstrapping and what are the relevant examples I have explained in today class. And one more thing is LEX, or the LEX is a computer lexical analyzer point of view. So how the I think the input stream that can be converted into sequence of tokens, it is not in a single step. So using the LEX, how you convert it, you make use of two compilers, LEX compiler and also C compiler. Finally, you getting target code is laid out, finally it convert into the input stream into some sequence of tokens. And what it have, it may have the declarations and some kind of auxiliary functions we are defining, and the pattern actions. So that is we have discussed in the lex. So I majorly have referred one good text, prescribed book is Compiler's Principles, Techniques and Tools. Refer the content is at the same time I provide another link also. So these are the key references I have taken for my lecture. And with this, today I'm concluding the class of bootstrapping and lex. Okay, thank you.
Like, share and subscribe. Hit the bell icon for more updates.